Hello everybody and welcome back to another video. I know you guys, well, for those of you taking AP Calc BC, I know you guys are coming up on this unit here, which is like applications of derivatives, especially if you started school around the same time we did, like early September-ish. So I kind of wanted to go over some practice problems, and it's not just going to be these set. I'll go over another one too, but let's just start with this, okay? We have a function of a particle's position, and it wants us to find the velocity at a specific time. So because it wants it at a specific time, we know we're going to have to find the derivative, right? And that's because velocity is derived from position. So we have to find the derivative of position. So we can say that x prime of t, or v of t, depending on which one you want, equals 4t cubed minus 4t, and this is just from the power rule, stuff like that. And we can say at 1 we get 4 because t is basically going to go away, minus 4, which equals 0. So we can say that this is 0, and since the velocity is 0, the particle is not going to be moving. So I think I have to erase this. Weird, it's not letting me click on it. Okay, so that was right. So next question. A particle moves along the x-axis. Okay, so it gives us the velocity. Now it asks us to find the velocity at time t equals 4. Well, since it gives us velocity, that's pretty simple. So let's see, 4 times 4 cubed is 64. Minus 3 times 4 squared, which is 16, so that's going to be 48. Minus 8 times 4, which is going to be 32, and then plus 3. So let's see what this is. 32 minus 45, which gives us negative 13. So let's put that in. A little slow today. What is the particle's acceleration? Well, remember, this is where the calculus comes in. Acceleration is a derivative of velocity. So here we would get this from the power rule. So let's find it at 4. Okay, 4 squared 16, so 48, minus 24, because 6 times 4, and then minus 8. So this is going to be 48 minus 32, which equals 16. Now, the next thing it's asking is whether the particle is speeding up or slowing down at the point. And when velocity and acceleration are the same signs, it's speeding up. The particle's speeding up. But when they're opposite signs, it's slowing down. So at this point, the particle is going to be slowing down. Yes, okay. So fourth question here. A particle moves along the x-axis. The function gives the position. Well, if velocity is the derivative of position and acceleration is the derivative of velocity, then acceleration is going to be the second derivative of velocity, or position, not velocity, sorry. So let's find the first derivative, which is just using the power rule. Remember, take it down, subtract 1 from the power. And then second derivative is going to be 6t minus 6. So let's plug in 3 for t. We get 18 minus 6, which is 12. So not that hard. I know, you think it's calculus, right? You think it's going to be very hard, very advanced stuff. And this can be tricky. Yes, some of the rules, but when you're just using the power rule is pretty intuitive. So velocity, we already said how to find this. X prime of t, which is going to be 3t squared. I guess you can try this problem, pause the video while I do this. And at 2, this is going to be 12 minus 9, which is going to be negative 9. And that's just from plugging in 2. So the particle is going to be moving left, because negative velocity is to the left direction on the x-plane. So that's going to be it for this section. And let me go to another one. Well, we have here the next section, which is rate of change in other applied contexts. So this question here gives us a model of a town's population. And it says, what is the instantaneous rate of change, the derivative, 6 years after the town was founded? So what I'm going to say is, considering we can use a calculator for this problem, I'm going to use a graphing calculator. So graphing calculator can help us find the derivative very easily. We go d over dx of 20 times 1 plus e to the, and we're using x as the variable in this scenario just because Desmos can't handle not doing that. And then we can say that our x equals 6. And we should be able to find the intersection point, 0.35. So we can say that this is going to be per year. Thousands, because the town is in thousands, the population is in thousands. Okay, so same one, calculator here, so we're going to use a calculator again. So what is the instantaneous rate of change for a set of 10 terms, and n is the number of terms. So this one's a little more easy because you don't have to use the chain rule as many times. You can kind of just, if you know, remember the natural log rule, right? We have our constant, and then it goes to the bottom, and then we still have to multiply by 0.9. And at 10, this would be 1.6 over 9 times 0.9, which would be 1.6 over 10, which would be this one. And the reason it's this one is because you're taking the like set or steps, and you're dividing it to find the derivative. You're dividing it by like n, which is, or you're doing it with respect to n, which is terms and not seconds. So that's why I say. Now here we find, well, we can just use a calculator for this, but you can also use the power rule. So let's find d over dx, because it's asking for the instantaneous rate of change of 0.0004 x cubed minus 0.001 x squared plus 0.1 x, and then we can ignore the 3200 because we know it's a constant, it's going to go to 0. And then it says when 100 gallons are produced. So we want to find this when x equals 100, because x is the gallons. So let's move our graph over here, and we find that it's 11.9. And since this is a derivative, remember, it's not just going to be dollars, it's going to be dollars per whatever we're doing with respect to, so gallon. Now, last question here. Let's move this back. What is the instantaneous rate of change when 50 kilograms, where x is kilograms, are produced? Same thing. We're just literally going to do the same thing. 0.001 x cubed minus 0.14 x squared plus 7x plus 160. And we're doing this when x equals 50. So what do we find? 0.5. So the answer is going to be, and remember, with respect to x is kilograms, so $0.5 per kilograms. And that is the end of this video. Thank you guys so much for watching. Have a good day.